Hello and welcome to Lesson 10.1. Today we're going to start looking at quadratic functions and their graphs. So ultimately we're going to look at quadratic functions in the form of y equals ax squared, and then we're going to look at functions in the form of y equals ax squared plus c. So a few things to note about quadratic functions. First and foremost, a quadratic function will always be written in the form of y equals ax squared plus bx plus c. Now you might be able to miss the bx or the c term and still have a quadratic function, okay? But ultimately, you have to have the x squared term to be considered quadratic, okay? And it has to be the highest degree. Okay, so once you have an x squared present, and that's the highest degree, then you have a quadratic function. So when you look at this equation here, my a and b values are just coefficients, and my c is always a constant. In here, I just have a couple different quadratic functions for you to look at. Notice this is a trinomial, so it does have the three parts. My a term is 3, my b term is 5, my c term is 1. They are all positive. If you come down to the second example, I have a negative a term and a negative c term, but I do have a positive b term, and that's okay, that will work. You can have coefficients that are fractions. We can have coefficients that are negative. This right here is just a binomial where I have my a term and my b term, no c term. And this one down here has an a term and a c term, but no b term. So all of these are still considered quadratic functions. When you look at the graph of a quadratic function, we say that y equals x squared is what we call a parent function. That means every graph is going to have a similar characteristic of y equals x squared. It might be wider, narrower, shifted left, right, up, down, okay, and so on, but it's still going to have the same shape. So when you look at the graph of a quadratic function, it's what we say is a U-shaped curve, okay? And so down here, we have that nice U-shaped curve, okay? Now we can also have an upside down U, so we could get a graph that looks something like this, but both of them ultimately have that U-shaped feature to it. And we call these parabolas. So a parabola is a U-shaped graph that belongs to a quadratic function. Now notice with a parabola, these are symmetric. And if you recall, symmetric just means that one half of the graph is the same as the other half of the graph. So these two sides are even, okay? Even on this graph over here, if I were to cut my parabola in half, I still have this half, which is going to be the same as this half over here. So parabolas are symmetric. We also have what we call a line of symmetry, and the line of symmetry is what separates the parabola into two halves. So here in this graph, I can see that my axis of symmetry is actually the y-axis. Over on the other graph though, my axis of symmetry is actually going to go through x equals -2. We do have what we call a vertex on a parabola, and a vertex is just another word for either a min or a maximum point. Okay, so notice on my first graph, my vertex is going to be right here, and it does fall on the axis of symmetry. And on the graph over here on the right, my vertex is going to be right here. That's my maximum point, and that also falls on the axis of symmetry. So for our first example, it says identify the vertex of each graph and tell whether the vertex is a minimum or maximum. So when I look at the graph here on the right, my vertex is where my graph is split in half, and it's the highest or lowest point. So in this case, my highest point is right here at the coordinate point 1, 2. So we would say that our vertex is at the coordinate point 1, 2, and this would be considered a maximum because my graph is facing downward. Likewise, over on the graph on your right here, my lowest point is going to be the coordinate point, so I'm going to put my vertex And the coordinate points for this are going to be 2, -4. And because this is a U-shaped graph, I'm going to have a minimum. Now when we go to graph a quadratic, for right now, we're going to have to make a table and plot some points. So for our first graph, it says we're going to graph y equals x squared. So what I'm going to do is I'm going to create a table, and I have my x points and my y points. I want to make sure that I have some negative points, some positive points, and 0. And I'm going to, I need to make sure that I try to get the vertex, or at least where it crosses my x and y axes, hopefully at some point in time. So if you don't know where else to start, I'm going to start out with -2, -1, 0, 1, and 2. So these are always my starting points unless I feel I have to adjust it. Then what I'm going to do to solve for my y values is I'm going to plug in -2. So if I plug in a -2 and I square it, I'm going to end up with a 4. If I plug in a -1 and square it, I end up with a 1. If I plug in a 0 for x squared, or x, and square it, I end up with 0. And then when I plug in my 1, I get 1. And if I plug in a 2, I get 4. So now what I'm going to do is I'm going to go ahead and plot these points. Okay, so right here you can see I've got all my coordinate points, and then I'm just going to come through and connect them with a nice smooth curve. And notice I have a U-shaped parabola that has a minimum or a vertex at the coordinate point 0, 0. And that completes this example. For part B, I now have y equals a -x squared. So again, I'm going to have x and y. I like the numbers -1, -2, -1, 0, 1, and 2. And again, now I'm going to go in and plug in a -2. So I have a -2 squared. Well, a -2 squared is 4, but then I have to multiply it by this -1 out here. So that's going to give me a -4. Then I have a -1 squared, which will give me a -1. 0 is going to be 0, and if I plug in a 1 and I square it, but I apply that negative to it, now I get -1, and then I'll get -4. And again, I'm going to plot my points, and then I'm going to connect them, and I end up with something like this. And for my final part of example 2, I now have y equals 4x squared. So what I'm going to do is I'm going to create my table, and I have x and y, -2, -1, 0, 1, and 2. And I really have 4 times a -2 squared, which gives me 4 times 4, or 16. Then I have 4 times a -1 squared, which is going to give me 4 times 1, or 4. If I plug a 0 in, I'm going to get 0. If I plug a 1 in, I'll get 4. And if I plug a 2 in, I'll end up with 16. So again, I'm going to plot these points. I can't get the coordinate points -2, 16, or +2, 16. So I just plotted the other 3 here. But notice that I get a much narrower parabola, but it is still U-shaped. Okay, so a few things that if you look back at example 2, parts A, B, and C, that you should have noticed. Okay, so when we have a parabola and it's in the form of y equals ax squared plus bx plus c, if your a term is greater than 1, your graph is going to be narrower, okay, just like we saw in part C. If your a value is less than 1, okay, so meaning that if you have something like 1/3 or 2/5, okay, something in between 0 and 1, then your graph is going to be wider. Okay, looking at the value of a will also tell us whether we have a U-shaped graph or the upside down U. Okay, so if that a term is positive, we get the U shape. If it's negative, okay, so U-shape meaning that it's going to look like this. If it's negative, it's going to be facing something like that. So for example 3, it wants us to order our parabolas from the widest to the narrowest. So if I look at my a values, I have a equals 3, a equals 4, and I know it's a -4, but I just need the numerical value, not a positive or negative. And I have a equals 1/3. So I want it to be the widest all the way down to the narrowest. So the widest is going to give me the numbers that are smaller. So that would give me y equals 1/3 x squared. And then I want to go all the way up to my biggest, because the bigger the number, the smaller it is, or the narrower the graph is. So when I look numerically between 3 and 4, 4 is going to be bigger than 3. Now, I'm not looking at positive and negatives. I'm only looking at the numerical value. So 4 is a bigger number, so that means that's going to be the the narrowest graph. So that means my second one then would be y equals 3x squared, and then the narrowest graph is going to be y equals a negative 4x squared. So this right here would be our final answer. And the last thing we're going to address today is the real-life applications of parabolas, okay? So quadratics are actually very, very beneficial in the real world, and these are used to model things like the height of a falling object, okay? We do ignore air resistance when we use this formula, but a typical formula that you may see is h equals a negative 16t squared plus c. So eighth is going to be the height in feet. Okay, notice our unit of feet. T is going to be our unit in time, and again, that is in seconds. And then C will be the initial height that your object is being dropped or thrown from. So let's take a quick look at an example of how we're going to use this, and then we can wrap up. So for example 4 tells us that a squirrel is in a tree that is 24 feet above ground and drops an acorn. It gives us the function h equals a negative 16t squared plus 24, and we want to graph the function. So instead of doing an XY table, I'm going to do a T for time and an H for height. And again, in this case, I don't really need negative values because I can't have negative time values. So I'm just going to go 0, 1, 2, and 3, and I'm going to plug these numbers in. So if I plug a 0 in, 0 squared times negative 16 is still 0, but it's going to leave me with 0 plus 24. Then if I have negative 16 times 1, that will give me negative 16. Negative 16 plus 24 is going to give me 8. If I plug in a 2, I have negative 16 times 4, which is a negative 64, plus 24. This is going to give me a negative 40. And at the point that I have a negative 40, I no longer need to keep going, so I can get rid of this 3. So now if I go and I graph my points here, I'm going to make this 1, 2, we can write 3 just because. And then each tick mark is going to represent, I think I can do 4s. So if I have 4, 8, 12, 16, 20, 24, 28. And now if I go to graph these points, I have 0, 24, which is going to put me right here. I have 1, 8, which is going to put me down here. So my graph is actually going down and looking something like this. And for our final example, it says, suppose you see an eagle flying over a canyon. The eagle is 30 feet above, which is why I have my 30 here. The canyon's edge, when it drops a stick from its claws, the force of gravity causes the stick to fall towards the earth, and we're given the function negative 16t squared plus 30. We're going to graph this again. So again, I have my time, which is really my x, my height, which is really my y. It does not make sense to have a negative time, so I'm just going to start right out with 0, and I'm going to go 0, 1, and 2. If I plug in a 0, I end up with 30. If I plug in a 1, I have 14, and if I end up plugging a 2, I get a negative 34. So again, I'm just going to come over here and do the same thing. So we have 4, 8, 12, 16, 20, 24, 28, 32, and 36. So again, when I go to plot this, I have 0, 30, so that's going to fall somewhere in here. I I have 114, and my graph then is going to look something like this. Please let me know if you have any questions. Otherwise, I will see you guys in class. Thanks and have a great day.